Example number 3. Suppose that a ball is dropped from the upper observation deck of the CN Tower in Toronto for 50 meters above the ground. Find the velocity of the ball after 5 seconds. Though experiments carried out 4 centuries ago, Galileo discovered that the distance fallen by any freely falling body is proportional to the square of time it has been falling. If the distance fallen after t seconds is denoted by ht and measured in meters, then Galileo's law is expressed by the equation s of t equal to 4.9 t squared. It is very difficult to find the velocity after 5 seconds because we are dealing with a single instant of time, t equal to 5, so no time interval is involved. However, we can approximate the desired quantity by computing the average velocity over the brief time interval. So in this case, for example, if we look at the time t equal to 5 and the time t equal to 5.1 second, then the average velocity is equal to the change in position divided by the time elapsed. So now let's calculate the change in position. If we have t equal to 5, then s of 5 equal to 4.9 times 5 squared. And if t equal to 5.1, then s of 5.1 is 4.9 times 5.1 squared. So the change in position will be 4.9 times 5.1 squared minus 4.9 times 5 squared. So what do? Is we are taking the distance at 5.1 minus the distance at 5, and then we divide by the difference of the time. So from 5 to 5.1, the difference of the time will be 0.1. When we calculate this, we will get 49.49 meters per second. So we will take two time and take the interval and doing the same process. So here is the result for that. If the time we taken from 5 seconds to 6 seconds, then the velocity, the average velocity will be 53.9. If we take the time from 5 to 5.1, then the average velocity will be 49.49. If the time from 5 to 5.05, then the velocity is 49.245. And the time from 5 to 5.01, then the velocity is 49.049. And if we take the time from 5 to 5.001, we will get 49.0049 for the velocity. So from this result, what we can see that if we take the time that is smaller, that is shorter, then the velocity closer to 49. So we can conclude that the instantaneous velocity when the time as 5 is defined to be the limited value of these average velocities over shorter and shorter time periods that start at 5. So the velocity will equal to 49 meters per second.